Comparing numbers in scientific notation, Chapter 2, Lesson 1, Part 2. So to compare number in scientific notation, there are two things we can do. First, you're going to compare the exponents. Okay, whichever number has the larger exponent is going to be greater. So here we have 10 to the fourth power. So 10 to the fourth is greater. 4 is greater than 2. So we automatically know 1.5 times 10 squared is less than 10 to the fourth power. But what happens if we have the same exponent? Here we have 2.8 times 10 to the negative 2 and 1.6 times 10 to the negative 2. So then you're just going to compare the coefficients. So 2.8 compared to 1.6. 1.6 is smaller, so we would say 1.6 times 10 to the negative 2 is less than 2.8 times 10 to the negative 2 power. So let's do an example here. 4.6 times 10 squared and 1.1 times 10 to the negative 2. Well, I don't have the same exponents, so I'm going to compare the exponents here. So I have positive 2 and negative 2. So positive 2 is always greater than negative 2. Again, positive 2 is greater than negative 2. So 4.6 times 10 squared is definitely greater than 1.1 times 10 to the negative 2. Let's do number 23. Identify the lesser number they're asking us. 3.3 times 10 squared and 1.8 times 10 cubed. So they're different exponents, so I'm just going to look at the exponents of 2 and 3. While 2 is obviously smaller, so 3.3 times 10 squared is the lesser number because it has a smaller exponent. In number 24, or I'll just write smaller exponent because they do ask you to justify your answer. All right, in number 24, we have 2.9 times 10 to the negative fifth and 1.7 times 10 to the negative fifth. Okay, so we have the same exponent here, so we can't compare that. So now I'm going to look at my coefficients, 2.9 and 1.7. So 1.7 is less than 2.9, so that means that this is my lesser answer. And this here would be enough justification. Number 25 and 26 wants us to identify the greater number. So 6.4 times 10 to the third and 9.6 times 10 to the negative third. Well, different exponents here, and I have the exponent of 3 and negative 3. So 3 is greater than negative 3. So that justifies that 6.4 times 10 to the third is greater here. Number 26, I have 8 times 10 squared and 1.5 times 10 cubed. Different exponents, 2 and 3. So 2 is less than 3, so that justifies that 1.5 times 10 to the third is greater. So you might be asked to compare a number that's in standard form to a number that's in scientific notation. So there's method 1, where you can just write both numbers in standard form. So in this example, we're comparing a ball bearing A, which is 2.01 times 10 to the first power, and ball bearing B, which is 15 millimeters. So we're just doing the conversion. 2.01 times 10 to the first is 20.1 millimeters. And then, the question is actually which ball bearing would fit into a tube with a diameter of 1.9 centimeters. So 20.1 millimeters, 1.9 centimeters is equal to 19 millimeters. So basically, which one is smaller than 19? 15 is smaller. It's kind of a loaded question because it wanted us to convert centimeters to millimeters, but we wanted to know which one was smaller than 19, which in this case is 15. So ball bearing B would fit into the tube. Method 2 would then be to write both in scientific notation. So we had 2.01 times 10 to the first power, the other one, and then we had 15 millimeters, which they converted to 1.5 times 10 to the 1 millimeters. And then they changed 1.9 centimeters to 19 millimeters to 1.9 times 10 to the first power. And again, they're making the same comparison since the exponents are the same. 1.5 is less than 1.9, which is less than 2.01. So it would both be ball bearing B. So whichever way you find easier to compare, you go ahead and do so. So in this example here, we have an airport that has 25,244 commuters in a single day. On the same day, a train station has 6.1 times 10 to the fourth commuters. Which location has the most number of commuters? So method one, I'm going to transform my scientific notation into standard form. So 6.1 times 10 to the fourth, I'm moving my decimal point 1, 2, 3, 4 spaces to get 61,000 here. So 61,000 is definitely greater than 25,244. So on that day, the train has more commuters. If I wanted to have done it the opposite way, I could have changed 25,244 to 2.5244 times 10 to the, I move my decimal 1, 2, 3, 4 spaces. And I would have compared 2.5244 times 10 to the fourth to 6.1 times 10 to the fourth. And because the exponents are the same, I would have seen that 6.1 is greater than 2.5244. Compare the decimals, or the coefficients. Excuse me, I'll use the right term. So again, the train has more commuters. And whichever method you find works best, you use that one. So let's do the last two examples here. Devin and Kirk each own a fruit orchard. Devin's fruit orchard is 15 hectares, and Kirk's fruit orchard is 15 times 10⁵ square meters. Who owns the smaller fruit orchard? So 1 hectare each equals 10,000 square meters. So that means I need to translate that 15,000 times 10,000 to figure out how many square meters I have. So that would be 150,000 square meters. A little extra work for that one. So now I have 115,000 square meters. And I need to compare that to 15 times 10 to the fifth. So I'm going to change 150,000 into scientific notation. My decimals here, I'm going to move it 1, 2, 3, 4, 5 decimal places. So that equals 1.5 times 10 to the fifth. So look at that. We have 1.5 times 10 to the fifth and 1.5 times 10 to the fifth. It looks like Devin and Kirk both own the same size fruit orchard. Number 29, the table shows the approximate elevation from sea level of 3 different mountains. Mount Elbrus is 5,642 meters high. Mount Fuji is 3,766 meters high, or 3,776. And Mount Kilimanjaro is 5.895 times 10 to the third. In this case, since I already have 2 in standard form, I'm going to go ahead and convert this one to standard form. It's 10 to the third power, so I'm going to move it 1, 2, 3. So this is equal to 5,895 meters. So which mountain peak is the closest to sea level? Remember, sea level 0, so that would be Mount Fuji, because that's the shortest one. And which mountain peak is the furthest? So that would be the tallest. That would be Mount Kilimanjaro, because it has the highest elevation. So that's it for comparing standard form to scientific notation.